Hi, this is the second video of Basics of Trigonometry, and here we will introduce a new measure for angles, that is the radian. The radian is considered to be a natural measure for angles, and let us go to the file and see what it is. Coming to define a radian, we will look at the circumference of a circle. We know that the circumference is equal to 2 pi r. That is 2 pi times the radius of the circle. 2 pi is around 6.28, and you can see on this drawing the circumference of a circle divided into 2 pi r. Each of these arcs has the length that is equal to the radius of the circle. So we have 1, 2, 3, 4, 5, 6 times the radius of the circle and another 0.28 times the radius. This is the division into 2 pi times the radius of the circle. The definition of radian is that 1 radian is defined as the angle that is subtended by the arc of length that is equal to the radius of the circle. So each of these angles has a measure of 1 radian. This one is 2. This is 1 radian. If we look at this angle, for example, this angle is measured as 2 radians because the arc here has the length of 2 times the radius. When measuring in radians, we divide the circle not into 360 degrees, but into 2 pi, that is around 6.28 radians. 2 pi is not an arbitrary number like 360. It is a constant that was given to us by nature, and that is why the radian is considered to be a natural measure of an angle. Next, you can see another definition of radians with an example. And let's go to see the connection and how we convert between radians and degrees. In this drawing, we can see that a complete circle is covered by 360 degrees, or by 2 pi, that is around 6.28 radians. So 360 degrees is the same as 2 pi radians. From here we can derive other values. 180 degrees is half a circle, because 180 over 360 is 1/2. And we take this proportion from 2 pi radians, we get pi. So 180 degrees is equal to pi radians. For 90 degrees, we take 90 degrees out of 360. This is a quarter of a circle, and we take a quarter of 2 pi. Of course, we can look at it as 90 over 180 times pi. Anyway, this is pi over 2, that is equal to around 1.57. And you can see this 1.57 on the circle. This is the angle of 90 degrees, and it is subtended by an arc with length equal to 1 radius and another part of the radius, which is 0.57 of the radius. So this is the pi over 2, subtends an angle of 90 degrees. Another example is 45 degrees. We take 45 out of 360. This is 1 over 8 from 2 pi, or a proportion of 45 from 180, that is 1/4 out of pi. So 45 degrees is pi over 4 in radians. In general, if we have an angle in degrees and we want to convert it to radians, we take the angle in degrees out of 360, that is the proportion from a full circle, times 2 pi. We take the same proportion from 2 pi. Of course, the 2 and the 360 is reduced, so we can look at it as alpha in degrees out of 180 times pi. This will be more convenient. And this is the angle in radians. So this is our converting formula. From degrees to radians, we take the proportion out of 180 times pi. The other direction can be derived from this formula and by the same principle. If we have alpha in radians, we take the proportion of alpha from pi and take the same proportion from 180 degrees. That is alpha in degrees. Let's use this formula to convert from radians to degrees. So pi radians is 180 degrees. What is 1 radian? We have to take 1 over pi times 180. Remember that pi is around 3.14, so 1 is a little bit less than a third of pi. So in degrees, it will be a little bit less than a third of 180, and that is 57.3 degrees. On the circle, you can see it here. This is 1 radian. It's extended by an arc with length of 1 radius. And this is around 57.3 degrees. I will skip these examples. You will have the answers in the file. To go to the 2 last ones. Many times the angle in radians will be in terms of pi, multiples of pi. When we have 1.75 pi, it means that it's 1.75 times half a circle, because pi is half a circle. We have to do 1.75 pi over pi times 180. This is actually 1.75 times 180 degrees, which is 315 degrees. That's half a circle and another 0.75 of half a circle. When we have 1.75 radians, it means an angle subtended by an arc with 1 radius and another 0.75 of the radius. Something like this. We have 1 radius and another 0.75 of a radius. And it's equal to 175 over pi times 180. That is 100.26 degrees. And this is it. This is the 100.26 degrees. Here, next in this file, you have exercises converting both directions, and you have the answers. So it's very important to practice. And we will go to another way to look at radians in degrees, and that is on a number line. For this, we have to memorize these 5 values, which is very useful to know by heart. So we know that 180 degrees is pi radians, 90 degrees is pi over 2, 60 is pi over 3, 45 is pi over 4, and 30 is pi over 6 radians. Based on the multiples of these values, we can find other values and place them on number lines. We will look at different scales. The first one is 180 degrees, which is pi radians. So 0 is 0, 180 degrees is pi, and 360 is 2 pi, and so on, 3 pi, 4 pi, and so on. We can also go to the negative direction and get minus pi, minus 2 pi, minus 3 pi, and so on until minus infinity and plus infinity. Here are some other scales of 90, 45, 30, and 60 degrees, and the radians. And these are the values that you need to know. It is very useful to know these values. You don't have to memorize all of them. You can use the above 5 values because all of these values are multiples. So, for example, if you want to convert 450 degrees into radians, you can look at 450 as 5 times 90. Now 90 degrees is pi over 2, so we have 5 pi over 2 in radians. Let's look at another example. If we want to convert, for example, 5 pi over 4 in radians into degrees, so we write it 5 pi over 4 as 5 times pi over 4. Now pi over 4 is 45 degrees, and we have 5 times 45 degrees. This is 225 degrees. Let's look at another example. Converting 300 degrees into radians. We can write 300 as 5 times 60. That is 5 times pi over 3. This is 300 degrees in radians. We can also write 300 degrees as 10 times 30 degrees, which is 10 times pi over 6, of course, the same as 5 pi over 3. So this is how you can convert without the calculator all these values. I added a scale here of units of 1 radians. This is not something you need to know by heart. It is just for more explanation and understanding. In the next video, we will introduce the trigonometric functions. And I hope to see you there.